Alright, what's up guys? Yeah, so we're jumping into our project. You already know the deal. We are picking up where we left off. It's been 3 days since we coded. 3 days ago, we actually were able to locate a text display bug and implemented a likely fix for it. Likely because we were not able to actually test this. So what we need to do is verify that the text, that the bug fix was indeed effective. So what we're gonna do is we're gonna go ahead and try to replicate the bug. Replicate that section of the game so that we can see if it still remains. Because I don't think it was an intermittent bug. I think that it's like a constant. Like it would happen every time based on what I saw in the code. So we ended up adding these two lines right here to fix the bug, and I think that it did fix it. I don't know. So we're gonna test. So what we need to do is we need to call wildcard meld choice prompt and to do that, we need to let's see what calls this. So we'll do Control F, and it's only okay. So we called in one place. So it's called in wildcard handler when the length of the play cards is greater than 0, or length of player melds is greater than 0. So this is for leftover wildcards, and this is not accounting for wildcards that are being added to melds that have less than 3 cards in them. Like, it's a separate wildcard handling situation as far as which code is executed. I don't think this code is executed, although it is basically like the same scenario. It's just a little bit more nuanced. So let's go ahead and crank up the server and the client. Okay, we have to do L for local, and there we have to do L as well for local, and it looks like we have something going on with a bug here. Sorry, but you didn't. Oh, that's weird. Okay, there we go. Now everything is working. So J's cranked up, and so is M. So let's go ahead and run through this beginning section. Takes a while there. Alright, there goes red 3. Just gonna draw from the stack, it doesn't really matter. Okay, so it's his turn to play. So we're gonna do all of them. And let's see if we'll actually be able to get to this section. Naturally, we're probably not going to be able to. Well, actually, yeah, we will, because see, this is what I was talking about. This is the alternate scenario. So we'll hit yes, and we're going to add to the aces. We'll add the joker. Okay, now I have to say no. Okay. Now this is where the bug was. So now we're going to. There we go. That was where the bug was. And it looks like the bug has been fixed. That was so easy. Yeah. Okay, yeah, so it's fixed. Cool. So that bug is absolutely fixed. That's great. So let's go ahead and pat ourselves on the back for that. And let's mark down that we were able to get it fixed. So we started at 12 o'clock and it took us only 8 minutes to do that. That's pretty good. Ran a game test and verified that the text, we'll call it the text display bug, multiple choice text 1 versus progression text display bug is fixed. Cool. So now we're going to the next step. Alright, so that's going to be, well, we can remove this now from pressing issues because we know that it's been fixed. Alright, modify unique save file client ID code. Check that IP address, we'll always check the unique file save client ID. Okay, yeah, we're going to take care of that eventually. We're not going to worry about that right now. So we're going to still focus on our current issue, which was the client Pi reconnect restructure the overall logic of client Pi to accommodate the reconnect system. And we're trying to figure out whether or not we're going to use game state or checkpoint system. And honestly, like, they're both virtually the same systems. They're just slightly different. So let's close these other files that we were working on. We'll go back to client refactor. Let me go ahead and make sure that the stream is indeed working. Virtually the same systems. They're just slightly. Right, paste this in. Click, make sure it's working. Let's pause this music real quick. Okay, yep, it is working. Cool. So we can close all that. Why did I have so many of those windows open? I don't know. We'll open Chippity Jippity because we probably will need some help at some point. And we should use Claude, right? Because Claude's the smartest. I just don't like the icon for Claude. I don't like the color of it, and I don't like how it shows the text on the side and it's a little bit slower. It's just a little things like that that bother me. But I think the quality of Claude is supposed to be better as far as the accuracy of its answers. So we're looking at dirt check. It's the Lord. We don't have to worry about dirt check anymore. Dirt check has been optimized so many times. Alright, so we're looking at the refactored structure here. Oh, I forgot to hit my timer, so we're gonna 68, so we're 9 minutes in, so we're gonna do 59, right? There we go. So 59 is set. Alright, so we have our refactored structure. Let's just review real quick what we have, and let me get rid of this search bar because it's taking up so much space. Just gonna clean So that looks much better. All right. So we have refactor structure. We have if name is equal to main, try, and then while true. Okay. This is the outer loop for menu screen. And then this is the menu screen section. If local save files game ID is equal to none, that means we can only start a new game. Current game multiple choice function would just be called as such with current game start new game. Blocking function via while loop. Okay. And we have elif local save files game ID is not equal to none. That means we can reconnect or start new game. Let's rephrase that a little bit, or rather, I guess you would want to opt to reconnect first. So we'll have that as the first option, which means in that case we would have reconnect to game first, and then we'll have start new game second. So we have these two options here. So if local save files game ID, and instead of writing it like this, we'll write it as it actually appears, which is CS save file pickle. Well, we would actually have to summon that data, right? So we would have to how would we do that? We need to load in that data. So we need to we're not importing it, right? Well, we could, I mean, could import it. I mean, that would be fine. Or we could read from the file. But at this point in time, I think that it would be essentially like the same thing. I'm almost certain that like reading from the file would probably be slower. I don't really know the performance of importing versus save versus a read operation. Let's ask Claude this. Python, would importing a file, a small save file, and checking a var from it be faster than using the read operation on the file and extracting it the same var? Let me help compare these approaches to accessing a variable from small save file. Using import, we would just have my save import save file value equals save file dot myvar, and then using read with open save file r as f read, and then parse content to extract. For small file importing would typically be slower. Okay, so it says importing would be slower because Python needs to compile the module to bytecode. The module gets fully executed. The import machinery has more overhead. Reading the file directly is generally faster for simple data access, but has its own considerations. You need to parse the data yourself, less reliable if format changes, and no validation of data structure. If you're frequently accessing the file, consider using a lightweight like JSON or INI instead. So create a benchmark script to demonstrate the performance. Sure. Okay. See, this is cool. Claude can do this. ChatGPT won't actually do this for you. Like, it won't actually run the test and everything and show you results. Look at this shit. This is pretty cool. So import time at JSON, import lib, OS, create our test files, set up test files, Python file. With open test var py w as f, write test value 42, and JSON file with open test var JSON, write as f, JSON dump test value 42, because you use dictionaries in JSON. Okay, and then with open test var text w as f. Okay, clean up test files, test var py, test var JSON, test var text for file in files. If OS path exists, file, OS remove file. If OS path exists, file, OS remove. If OS path exists, pycache import shuttle. I can't remember utility. That's anyway. Shuttle rm tree. Okay, pycache. So that's removing these test files after. Benchmark import test var, import lib reload. Why do we do that? That's very ensure fresh import each time. Okay. Okay, so this is like whenever you call the function, it will reload it. So that ensures the import occurs each time the function is called instead of each time the function is defined with the import statement. Alright, so we have clean up test file, import the ensure fresh import each time, return test var test value, import test var, return test var test value, benchmark read with open test var text r as f, f content f read, return int content split equal at index 1. Okay, benchmark JSON with open test var JSON r as f, return JSON load f at test value because we saved it as test value. Split at the equal sign and then index 1. I'm confused as to why that would be considered. Oh, it's splitting from here. It splits like at this, so this would be 0 and then like this would be 1, right? So something like that. And then we have test. Okay, no, it is import read JSON. Gotcha, that's the 3 that it has. And then run benchmark number 10,000, set up test file. And then set up test file is, okay, so it runs that first. And then it does import time at time at benchmark import number, read time at time at benchmark read number, and JSON time at time at benchmark JSON number. Okay. So it just passes that function, okay, right? Because I usually just do explicit code instead of function, but That's results, print, new line, results for number for 10,000 iterations. Why is it number, comma? Method less than 15. What? I don't understand this. Times seconds. What is this less than 15? Like, what is this doing? So, what is the above line doing? Then we have find fastest method for relative fastest time equals the min of import time, read time, JSON time. Okay. Results, import. Import time. And that could have been a tuple. I don't know why they made it a list, right? They could have just done this as a tuple. Tuples are faster to create, aren't they? For method time and results. Method time and results. So why does it say method? This is, I don't understand this. The less than 15. This is like some sort of code for something. Like, I don't know what that is. I don't know what's up with that. Anyway, let's just, and then times 45. Why do we do times 45? Okay. Alright, so then for method time in results, relative equals time divided by fastest time. Why is it dividing the time? Bro, what is this? I've never seen, like, it's probably right. I'm just like, what is this? I'm learning here. Okay, and then finally clean up test files. So this is a test. I could have done the test this quickly. Like, I could have already tested them. I could have tested it this fast. Like, I could have ran this, but I do like to see Claude's way of writing things, because it reflects how humans write things in general. Like, you know, the consensus. So I like to see how other people would write it versus how I would write it. And not all the time, but, you know, every now and then I usually have a little learning session when I code. I'm gonna take that fucking jacket off, dude. It's straight up, like, got hot. It's because of this heating pad. I'm using this heating pad on my back, and it helps with my back pain, but man, it gets so hot, it will make you just start sweating even when it's like really cold out. Anyway, so let's see what we got here, and what are the actual results. Did it run the, like, did it execute the code? Oh, so it didn't actually execute the code. So it created the test file, but did it actually like run it. Okay, let's read what it said. I'll create a benchmark script that compares the different approaches. The script creates test files in 3 formats, implements 3 methods of accessing the variable, uses time it to benchmark each method, cleans up the test files afterward, shows relative performance compared to the fastest method. Okay, so the division was to convert it to like percentage, right? Like, you know, I think like this one was 120% as fast as etc. or whatever, or relative to the fastest one, so it would be like 80% as fast, 50% as fast, or whatever. You can run the script directly to see which method is faster on your system. The results may vary depending on your Python version and system configuration. We take about modify the benchmark anyway. You can have more file formats like YAML or INI. Oh yeah, and also I want to know, what is INI? What is INI versus INI? Should I use YAML or INI or JSON? Is there a best option? And you know, I just like to, I know that there's probably not a best option. I just like to ask it that to see, you know, what the consensus is as far as what is typically preferred. Usually what is typically preferred is the best option for reasons that I might not know about, but usually what people use most is the best option. So okay, benchmark. So it created the benchmark script. We asked it a question about what some of this weird syntactical gobbledygook meant. It's -15. I don't really understand why I did that. So it says import reload. Yes, exactly. Without this, Python would use the cached module after the first import. When you do import test var, Python stores the module in sys modules, and subsequent imports just return the cached version. Reload forces Python to actually reload the module from disk each time, making the benchmark fair. So you know, oh, because the first, no, that still wouldn't like influence the first. I was gonna say, oh, the first benchmark would include the import, but that's not actually true. Or does it? Did we actually import? No, we imported at the top of the file, so it doesn't really make sense actually. Anyway, it's like, you know, Claude, I already learned Claude is not amazing at creating code. It's good, but it's not amazing. It's a great help, but it's not by any standard. The formatting lines. Import test var actually loads from disk, and then if you run it again, it just returns cached version. With reload, import test var loads from disk, forces new load from disk. Gotcha. So import lib reload. That's actually important because, well, I've never used it before. It's just cool to learn that. I'm like, okay, I didn't know about that. So that's something I've just learned about. Now we have the formatting lines are using Python's f-strings for table formatting. Formatting lines are using Python's f-strings for table formatting. Okay, I understand that. Table formatting. -15 means left align and pad to 15 characters. Oh, okay. I've never used that. I have never used table formatting before. Okay, so that is something I just have never used before, and this is just, you know, this is how I like to learn about new things, is in small little sections that apply to the code that I'm actually working on. So it's kind of like a mini class. I like to take a little mini class every time I do a coding session. Anyway, so we break down the format so as far as we have -15 is left align, so the negative means left align, and 15 means 15 characters, and then method 15 takes the word method, left aligns it, make 15 character wide space. This creates column headers that look like, so instead of doing 15 actual spaces, that would just not even like get registered. Do that to so instead of just typing out a regular string and then typing method and then spacing 15 times, you just do an F string inside of the curly braces and use that -15 and the F string magic understands what you're doing and has its own little language there. Okay, cool. Okay, then for the data row, F method 15 for F, left align 15 characters wide for method name. Okay. And then for F is dot is fill with dots. 4 decimal places. And then 4 float. I don't know what fill with dots is. I don't really understand what fill with dots means. Okay, so instead of blank spacing, it would be 15 spaces that are filled with dots. It's just kind of like, why wouldn't you just write? I mean, whatever, that's cool. It's cool. I get it. I mean, hey, it's faster, right? Technically, once you learn it, okay. Sure. Yeah, maybe it's necessary for certain things. Yeah, probably. Okay, so 2F, would be 2 decimal places for float, and then fill with dots, and then 4F is 4 decimal places for float, 2F is 2 decimal places for float, and why is this? It doesn't say. Okay, so the produce output like this. F name less than 10. Left align 10 characters. Gotcha. Name right align. Okay, I see. Gotcha. Then number is 3149, and then number, and then 2. So the dot. I put 3.14. Also means also 2F. The dot there means what exactly? What would be different if we just used 2F instead? Okay, And we still don't know which one is actually faster, so we'd have to run that benchmark. We'll run the benchmark in just a second. I just want to finish this last little learning session. Let me address each question. INI files, initialization files are simple configuration files with a basic structure. So we have section name, key equals value, another key equals another value, another section setting 1, 2, 3. And then JSON is fast, widely supported, strict syntax, good for data exchange. YAML, human readable, supports comments, complex structures, but slower and more prone to syntax errors. INI is very simple, human but limited, no nested structures. Best choice depends on your needs. Use JSON for data exchange, simple configs, performance critical apps. Use JSON for data exchange, simple configs, performance critical apps. Use YAML for complex configs when you need comments, human edited files. Okay. And then use INI for very simple configs, backwards compatibility, Windows settings. Table formatting goes beyond what I showed. Here's more. So you can use up arrow is centers title in 20 spaces. Oh, that's cool. And then different fill characters is asterisk left 20 fills with. Okay, gotcha. So the character you want to fill with precedes the alignment indicator symbol. So here we have asterisk and then left alignment and then 20, so it does 20 asterisks. Then we have dash right alignment 20, so it aligns the name to the right and precedes it with 20 dashes. And then we have name equal centered with 20 equal signs, so there's 10 on each side. And then you can combine it with number formatting, so we have 1, 2, 3 val 0 1, 2, 3 and 0. Okay, and then right indent and then 5. Okay, so you have aligned to the right. And you want it to be 5 spaces total. And you precede it with zeros that would accumulate with the actual val you're printing to reach the total 5 characters. Okay, so that's a little bit, that one right there, that last one is actually a little bit complicated, I'm not gonna lie. Well, not complicated, but like it looks so much like a math equation that it is kind of confusing. You know what I mean? That just looks confusing. I'm not like, just straight up, and just kind of weird. Like it's kind of like encrypting. For what reason? It looks more like encryption to me, some of this. And about .2f versus 2f, the .2f is crucial. It separates the width alignment specifiers from the precision. So number 314159, okay baby. And we have printf number .2f, just precision. Okay, so the dot indicates precision, where the 2f is width alignment. So print number .2f prints 3.14. It's 2 decimals. Then number 6.2f. Width is 6. Precision is 2. So you want 6 total spaces. And then it printed with precision to the second decimal place. So you got 3 here and then 4, 5, 6, which is just blank spaces. Then you have 0, 6, 0.2f with 6, 0 padded. So padding precedes with, and then precision 2. So 0 padded means you're using zeros to fill the empty space as opposed to blank spacing. So if you don't put any character, it uses blank space. If you put a integer, it uses that integer as the padding. Otherwise, it will use blank spaces as the padding. And it still has the 6 indicates the width, and then dot 2f. If you try to use just 2f without the dot, Python would raise a value error because the format specification is invalid. Okay, so basically dot 2f is, you have to have the dot indicates that you're dealing with a decimal. It needs the dot to separate width alignment from precision. The general format is value, and then we have left, right, or up for alignment. Left alignment, right alignment, center. Then width, baby. And why do you have a question mark there? No. Then you have width, which is total field width, optional, precision, decimal. So you can have any of these without the others independent, but if they're all there, they have to be executed in this order. And then you have, so total field width. Okay, so if you don't have the dot, then it would confuse that with total field width. Yeah, I understand. Gotcha. Precision is for decimal places for floats, and then we have F for float, for decimal, S for string. And what's the difference between float and decimal? Last one, that'll be the last one. What's the diff between float and decimal? I'm confused. I thought decimal and float was the same. But that's why I have important differences in how they handle numbers. So floats are binary based representations with fast calculations built into Python. It has precision issues with certain decimals. Classic float precision issue. 0 plus 0.1 plus 0.2 equals 0.3. When you print, it shows 0.30004. I wonder, bro. Is that why I have those weird issues with the card movement? Because I'm pretty sure I use float for all of that. And I did not know this. I did not know that float had see my piece, baby. I got one for me and one for each of my babies, okay? So I'm the black one. Zeta's here. This is Kyron. Israel. And I need to reorder them so that I'm on the other side and that I actually had a purple one for Zeta, but I don't know where it is. So figure it out, but I actually like having all 4 of these. It's represents my babies. Anyway, so we have the float. The float is didn't know this, man. This is new to me. Decimals, decimal dot decimal, decimal base representation, slower calculations. So float is basically like a binary represented decimal for faster calculation, but is not perfectly accurate. Like, man. Well, then if that's the case, why do they use floats by default? I just feel like aren't floats used by default over decimals? Like when you write out in decimal format, Python treats it like a float, doesn't it? I've never seen decimal type. I always see float type. I just straight up thought that float was the way that Python described decimal. I thought it was just a different word for decimal, but apparently float is an entirely different data type than decimals. So decimal dot decimal is a decimal base representation, baby. It's slower at calculating. It is need to import. You have to import decimal. Okay, this is gonna make me cry, honestly. I am feeling like, why would you ever make decimal? Man. See, well, Python does come with these things called instructions, which are called the documents. And maybe if I read the documentation more, I would know that. But I'm more of a, I'm not gonna read the instructions kind of guy. I'm just gonna jump in there and start working on the project kind of guy. Hey, it got me this far, right? Anyway, it's the exact decimal representation, meaning that there's not the precision issues. So if you do 0.1 plus 0.2, it's always going to be exactly 0.30000 for infinity, not be off by 1 gazillionth, 4 gazillionths, whatever you call that number. So you have to import decimal. You would use float for scientific calculations when speed matters, when absolute precision isn't critical, and general number crunching. Use decimal for financial calculations when you need exact decimal representation, accounting anywhere you can't afford rounding errors. And that is kind of what I deal with the card movement. All of that uses decimal, it uses that in rounds to the closest single digit in various, ways and places to determine how the pixels, where each card is located pixel wise on the screen. So I wonder, would converting these floats to integer decimals be beneficial as far as the rendering of cards on the screen? Now, they may not offer any benefit. That is a very, very small precision issue, and I would like to think that wouldn't actually matter. But I did not know that, so it's good to know. I'll put this not in pressing issues, but I will put this in non-pressing issues for something to consider, and really just to remind myself of this. Float versus decimal. And so this is something new that we learned. Oh yeah, guys, it's Mardi Gras season, so we got parades. Like, parades are probably about to start, right? Like, they're about to start some of those earlier ones. So Mardi Gras is what, like February 15th, some of that? I don't know. Maybe I'm totally wrong. I live in Louisiana, so I should know this. I've lived in New Orleans for a large part of my life, so anyway. So we learned that float type is different than decimal type. Specifically, float less accurate to a very small degree. And we're talking like to the fucking 12th decimal place. And decimal has to be imported and has perfect precision is slower. So yeah, we did not know this, and now we do know it. So we have float is less accurate to a very small degree, and it is the default for decimal numbers in Python. And this is a default type. Less accurate, and then is slower. Is faster because is actually binary representation of number, and is slower, I'm guessing, because it has to be in because has to be converted to binary form, something like that. So I wonder if the precision issue has to do with the fact that the binary representation of the number dictates that, or if it's like actually some sort of like mathematical capability of floats. I'm really not gonna dive that deep, it doesn't matter. But anyway, we are done with that, so we can to the next step, which I would say is running these benchmarks. I just want to ask him, can you run the benchmark file you sent me and show the results? I'll modify the previous benchmark to include print statement showing the values and then run it. Cool, yeah, so instead of me having to test, so actually if I want to write up a test, a speed test, I can just get Claude to do that. That's cool. I didn't know that. Granted, don't trust it, and you have to review it as a student, even though sometimes you're like the student, So he modified the previous benchmark to include print statement showing the values, and then he ran it. So he's running on this and produces output similar to this. So he set it up to test file and created test_var py, created test_var JSON. Create test_var text, running benchmarks with 10,000 iterations. Each verifying methods return correct values. Okay, so they do return the proper value each time. And then we have results for 10,000 iterations, method time, seconds, relative speed. Import 1. Okay, so import 321%. It takes 320% the time that it takes JSON. So JSON wins as far as speed goes. So import takes 1.2 seconds. Read takes a half of a second, and JSON takes almost a third of a second. And so the exact numbers will vary depending on your system, Python version, and other factors, baby. On most for systems, the JSON method is typically fastest followed by direct file reading, with importing being the slowest due to Python import machinery overhead. Would you like me to modify the benchmark in any way? For example, we could test with larger files. We could add more iterations. We could test with different types of data, baby. Add memory usage measurements. No, that's fine. Thank you. I don't want to tell you thank you because that'll use up one of my tokens, whatever you call it. Okay, so I'm bombed out and depleted, bro. Dave Chappelle said that? Bombed out. Bombed out and depleted. I am very tired. Here goes my protein, last of my protein coffee. Alright, so we have determined that JSON is fastest, and that's why you always hear about JSON. JSON is probably the way to go. Everyone uses JSON, so we're probably going to use JSON instead of pickle, okay, baby? We're going to use JSON instead of pickle. So let's do that. Let's go over here. We're gonna put this in the current issues. We'll put use JSON instead of pickle for save file. And let's just ask one more time, why would I use pickle instead of JSON for save Python? Write down when you might use pickle or JSON over storing data in Python. Pickle advantages can save nearly any Python object directly. You can save complex Python objects. Okay. Gotcha. Okay. Right. And okay, I understand. Preserves Python specific data types, simple sets, custom classes, usually more compact file size. Can save multiple objects to same file using pickle dump. Save multiple objects to same file using pickle dump multiple times. Okay. JSON advantage is human readable. Okay, so when you look at the pickle file, you're not gonna be able to read it from unless you can read fucking binary or whatever. Across different programming languages, it's safer. Pickle connects. You just go to the file it's tampered with. Right. You import it, it executes the code, so it's a security. Right. Like so, technically, if somebody modified their, well, it wouldn't modify my pickle file, like of the project. Anyway, I understand. Okay. And it is web friendly. Here's some data in JSON. So you import JSON is a dictionary. So use game data, score, position, inventory. Save with open. Save JSON W as F. JSON dump game data F. And then load. Save JSON R as F. Choose pickle when you only need Python compatibility. You have complex Python objects, and then font size matters. Security isn't a concern. Choose JSON when human saves. You might need cross-language compatibility. and security matters, and you only need to save basic data types. Okay, well, you know what? Actually, guys, actually, um, technically, based on this, I would probably want to use pickle because I am going to need to save complex Python objects, such as, you know, complicated Python class instances with various attributes. And I want to make sure that classes and functions. Well, I don't know. Do we need to? We don't need to save functions. We're not going to need to save classes. We're going to need to save class instances, right? We're going to need to save, like, I mean, I feel like we would have to save class instances at some point. Let's see. So if what class instance would we have to save? Well, I'm not sure. Let's look. So I was thinking like the client object, but the client object, what kind of attributes does it have? Okay, so it does have a lot of different attributes here. It has all these. So as opposed to like, so with pickle, we could just straight up save the client object, but with the JSON, we might not be able to do that, and we would instead save each individual data point associated with the client object, such as the expect counters, etc., etc. So you would do a one by one, and like that is actually how we would be saving. We would be saving in terms of each individual as we modify it. So I think from that perspective, as long as JSON could handle float, I don't know about data, like received data is what? Received data is like, what is that even? What is received data actually? So this is what we need to consider. We need to make sure that it can handle whatever type of save we use. It can handle the various types of objects that we throw at it. So we have type is network data, but I don't think that's an accurate description of what the Python data type is when we're actually executing that code. It's not a network data type. That's just like what I wrote in English to as far as how I understood it. So received data is the actual receipt, like what we receive through the connection, and that is unserialized data. So that means it is what? Bytecode? Like the type of data this would be bytecode. Yes, receive returns raw bytes because network sockets transmit data as bytes. If n receive con internally handles unpickling, it means receiving. Okay, so it does. Okay, so yeah, right. I forgot. So client side, we have it modified such that received data actually internally deserializes the data. It means receiving serialized. So if it internally handles unpickling, it means receiving serialized pickled Python objects that were converted to a byte stream for transmission. So Python pickled data and then converts to bytes. Socket send, and then the receiver side gets the raw bytes and then converts back to Python object. Right, and that Python object is actually a list, right? Yeah, it's a list of data that has been changed. So let's see. When we do .send, data is pre-serialized data, which is, well, okay, so it's actually a tuple. It's the current client ID, the receive verification. Well, that's not accurate. So that's different. That's, let's see, message header data, send all. So data equals pickle dumps current client ID requested, send ID requested data. And what would the requested data be in this case? The requested data would be the send data storage dict. So it's the associated change attribute list. So it's a list. Okay. Right. Because we send in basic format. We don't send we don't send Python objects over the network. Remember? That was the problem. How to do that. And you can't actually send Python objects over the network. You have to baby, here's what you have to do, okay? You have to basically create what we call a skeleton. We create skeleton form of the data, which is just a simpler, more easily transmitted version. It would be like, instead of trying to send a deck of cards through the mail, you would just send a piece of paper that has each card's data listed on it, like 2 of hearts, 2 of diamonds, 2 of club. You know what I'm saying? You would just write like 2A, 2C, 2D, 2H, whatever. So anyway, you get what I'm saying, right? So as long as JSON, why are we talking about this? Because as long as JSON can handle the list type and the tuple type, because we send tuple, we send this tuple, but it consists of an ID, integer, and then a list. And then we also have, and the list consists of basic data types such as integer, string, list, dictionary, no Python objects. I mean, well, yeah, no like class instances, you know what I'm saying? No, oh, no. I'm sorry. It wasn't Python objects. It was Pygame. Right. So we couldn't send Pygame data And since we're using Pygame as the engine, we couldn't transmit the cards directly because the card is a Pygame object, and that's like too complicated or whatever for the send all method to, or you can't serialize the Pygame stuff correctly, and converting it to skeleton data is also just a lot faster because, like I said, instead of sending an entire deck of cards, you're just sending a little piece of paper. That's so much light. It's lightweight. It's way, anyway. So that's why we had to do that. But long story short, as long as JSON can handle basic Python data types such as lists, strings, integers, dictionaries, no like Pygame objects, we're not even sending class instances, we're sending really basic data types. Okay, so actually, whenever we receive, it's my break time, but I'm gonna go a little, finish this point up. So whenever we receive data on the client side, we are this received data is actually what type? It would be a well, it would be a tuple. Yeah, it would be a tuple that would consist of integer, or a list, integer, or an ID, and then integer, or integer. So integers and lists are what we would be dealing with there. Now, whether or not you would argue that we would need to save the data before it gets deserialized in its unserialized form, that is a separate debate that comes down to nanoseconds and well, I mean, you could probably make the argument that it would take just as much time to receive the unserialized data and the serialized data and unserialize it as it would be to receive the serialized data and to then save it in its serialized format. You see what I'm saying? But you could really make that argument throughout the entire process to avoid saving ever. It's silly because obviously you do need to save frequently and very frequently, but do you need to save that frequently? Well, actually, you might really want to do that. We might want to save the before we do anything to it. You know what I mean? Let's say we receive something in the mail, or we let's just say that mail could immediately disappear at any given moment after we receive it. The very first thing we're going to want to do is create a duplicate of it, right? So that if that one that you received disappears, you have that duplicate. You see? So if you even took one step before duplicating the object, then between the time of the first and the second step, that object disappeared into thin air, which could happen because disconnects can happen at an arbitrary point in time. There's no you know, whatever. We know how it happens. It just happens whenever it happens. And it could be at any point in the game. So yeah, you considering that the recovering sent data is time consuming, complicated, error prone, etc. I actually do think that saving the data immediately before we even convert it into its originally sent form would, like, before you even unbox it. So you don't even unbox it, you literally duplicate it at as soon as you see it. So I'm gonna add a note here. Well, I'll add a note, and I will also add I will also add, and we already have our snippets. I quit using my snippets. Why? So we have create a comment for the below line 2, 3, 4, 5, 6. And now we have comment created 1, 12, 24. And we're going to say determined that we need to ensure we are saving the data prior to the serializing data, since data recovery inter whatever you want to call it, like trans network to network data recovery is time consuming, error prone, etc. It would be nice to save it immediately after reception. This implies saving the data prior to deserialization, i.e. code and the network function, the end.receive. Isn't that what it's called? Yeah, end.receive function to handle this, the saving. Yeah, baby. So we're gonna copy this and we're gonna add this to things to do. So we're actually not gonna use JSON instead of pickle. No, actually we are. So we'll write determine which to use. Say pickle converts complex Python objects, but it's a little slower. Not human readable. And then we have JSON, which is converts simpler Python objects, is faster, and is human readable. We'll need to say what data types exactly can handle instance objects. Pickles, instance objects, etc. Okay. We're gonna put JSON at the top because it's probably the one we're gonna use. And I actually like my stuff to be properly capitalized and stuff. Determine which to use. JSON or okay. As far as speed goes, well, I'm actually not sure if it's... I don't actually know if that's true, if JSON is faster than Pickle. You know what I'm saying, baby? Because JSON may be slower than Pickle. You don't really need to read it. Although we don't really need to read the file. Like, I don't think we do. I don't imagine that I need to open it up and, I mean, well, yeah, we wouldn't actually have to read it. We would have to have an interface in the client file, obviously, that associated each object in plain English with the associated saved object. But we wouldn't actually need to like open up the file and read it. You know what I'm saying? So, I need to go eat lunch, but I'm really caught up in this moment, and I don't want to miss a thing. You know what I'm saying? So let's power through a couple more minutes. So the byte stream, let's read the rest of what Claude had to say. Receive data and receive data, blah, 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 blah. Yes, she turns up, blah, 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 blah. Okay, now we have, byte stream might look messy, unreadable because it's a binary representation. Okay, so either way, if we saved it prior to serialization, or prior to deserialization, and we actually do need to save received data CS prior to deserialization. Cannot cat like need to save data prior to deserialization. Save the data prior to deserialization. Okay, so let's consider this. So we need to actually put this in its own thing. So, which option we choose. Actually transfer this, so it doesn't actually matter if it can handle those, but what we do need to bytecode has to handle this type. Tio, baby, it has to handle that type bytecode, and then we would write the same thing here. Clean up our notes a little bit, and I don't know why, but I just like I've been having like a little bit of a sore throat for a long time, and it's not bad. It's very mild, but anyway. I wonder why. I don't smoke or anything, or vape or any of that. It's probably from the cold. Maybe I have a touch of like strep or some shit. started to find that my immune system's finally gotten a little bit better to where like when I do get sick, I don't really get sick like I used to. I mean, I still do every now and then. I used to get sick a lot, and it would be like pretty severe symptoms. Now, past couple years, it seems more like when I get sick, the symptoms are very mild, like so mild that I'm actually not sure if I'm sick or not. You know what I mean? Maybe I do actually have some sort of viral infection, and I don't even like, you know, like symptomless COVID, where people just kind of get COVID and they're not coughing, they're not sneezing, they don't have like a fever per se, but they just kind of feel tired, and then they like go get tested and they're like, wow, I actually had COVID, they didn't realize. So maybe that was why I had been so extra tired. That could be contributing to that. Anyway, so we do have to determine use JSON instead of pickle for save file. It's faster. What tips can handle? So we need to figure this out. And you know, this is all a sidetrack, right? From the initial question of what? Well, the initial question, well, it was about choosing our save type. Yes, we didn't. Like, that's not really a sidetrack. That is necessary because the pseudocode we have implemented requires saving stuff like the very first line, like the very first, yeah, the very first thing is we have to create code. So we have to put create code, and then create code, and we'll say what for loading in game ID from save file. Either okay, so import or right, that was where we started, was import or read op. Claude says read is like 3x faster than improt, and it does make like more, it's more fitting because we don't need to import the file. We don't, like, you know what I'm saying? It's anyway, you probably understand. We don't really need to do it. If the shoe doesn't fit, why wear it? When you have a shoe that fits perfect. Anywho, let us move forward, and moving forward would be actually break time. I'm gonna go ahead and take break. I'm gonna go eat some lunch and take a little break, and I'll come back and might go to the gym. I'm probably not gonna go to the gym because it's Sunday. I'm like really tired. I feel like I worked out super hard yesterday. I broke my record on jogging, and this was after a really intense workout. After I did, like, I did everything. I did chest, shoulders, biceps, triceps, pull-ups, dips, sit-ups, jump rope, leg workout, what do you call it? Quads, thighs, calves. I went and did jogging last, and I broke my record. I did 8.8 miles per hour, which was a 6 minute and like 55 second mile. 6:53. Actually, I think I ran a little faster before when I came back fresh, but that was like not after a workout. That was completely fresh, and that was off of like a 4-day rest. And I think I might have ran like a 6:45 or something. So was probably the equivalent of a 6:30 if I would have been fresh. Like if I would have been fresh and not had worked out previous, I probably could have ran a 6:30, which is like a 9.5 mile per hour mile, which is pretty fast. A 10 mile per hour mile is a 6-minute mile, and a 6-minute mile is like what runners aim to. Like if you're a runner and you run every day, like if you can hit the 6-minute mark, you're like a beast. And I don't really run every day, and I do other workouts. I don't just do cardio like most runners, just really work on cardio, really slim and all that. But anyway, that's neither here nor there. I'm just proud. I did really great. Anyway, I'm gonna go take a break, go eat some lunch. We'll come back, do some more, and I'll see you guys then. So, peace.